Hello and welcome to today's webinar, Kubernetes, VMware, and NetApp, a match made in container heaven. Thank you so much for joining us on the webinar today. This event is brought to you in partnership with our friends at NetApp. We've got a great event lined up for you. Before we get started, there's just a few things that you should know here about the event. My name is David Davis of Actual Tech Media, and I'll be serving as the moderator. As always, here at Actual Tech Media, we want these events to be educational. We're all former IT professionals ourselves here. We know how tough it can be out there in the world of IT to solve your challenges. There's always new innovations. There's always new threats, new concerns, new projects. It never stops, and this event is here to help you hopefully overcome some of your challenges and get all your questions answered. We encourage your questions there in the questions pane of the audience console, and we'll be doing a Q&A session at the end of the event. So keep those questions coming throughout the webinar. We even have a best question prize to help encourage those questions. I'll talk about that here in just a moment. We also have a number of resources there in the handouts tab I want to call your attention to. I see a link to the NetApp and VMware homepage. There's also a link to try Astra Control for free, and download Astra Trident. These are solutions that you'll be learning about on the webinar today, but make sure you keep those links in mind during the event. I'll remind you about them, of course, at the end of the webinar as well. At the end of the webinar, we'll also be announcing the winner of our Amazon $300 gift card door prize. If you're watching this on demand, of course, that drawing has already occurred. The prize terms can be found there in the handouts tab. And as I mentioned, we also have our best question prize for an additional gift card, an Amazon $50 gift card. We'll contact that prize winner after the event. But of course, you have to ask a prize to be entered into the drawing. And with that, I'm excited now to introduce you to our two expert presenters. Welcome to Chance Bingen, Technical Marketing Engineer at NetApp, and welcome Alan Cowles, also a technical marketing engineer at NetApp. Chance and Alan, it's great to have you on the event. Before I first hand it off to Chance, we've got a quick poll for everyone out there in the audience. The question on the screen is, what is your current Kubernetes solution? And as you know, there's multiple flavors of Kubernetes in the market. So we've tried to represent some of the most popular there on the screen, but perhaps you have one that's not listed. That would be the other option. Perhaps you're using multiple. Feel free to select multiple, or maybe you're still learning about Kubernetes and haven't implemented it yet, and so you can choose none. But we appreciate your feedback there on the poll, and looks like there's a lot of good responses coming in. It's hard to select a winner here. I see definitely that Tanzu and OpenShift and the hyperscaler solutions, Azure, EKS, GKE, those are kind of the leaders there on the poll. So good feedback. Thank you so much. We'll have other polls here during the event. But for now, I'm going to hand it off to you, Chance. Take it away.
Thanks. Yeah, it's great to be here. Appreciate everyone joining. So we'll go ahead and dive into it. Today, we're going to be talking about Kubernetes, VMware, and NetApp together, talking a lot about the VMware Tanzu portfolio. And that's kind of where we're going to get started there. So we're going to talk about the NetApp and VMware partnership. We're going to go ahead and talk a little bit too about the Tanzu portfolio. So talking about, all the different things that make up Tanzu. And Tanzu is one of those things. It's really not just one product, right? And I saw a lot of you in the poll are actually using it already. That's fantastic. But it's kind of like Microsoft Office, right? You can have Microsoft Office, but you also are using Word, Excel, PowerPoint, right? All these different things are part of the Microsoft Office portfolio. And that's kind of what Tanzu is. We'll look at some of the options with how you can manage Tanzu applications and using application data management for stateful application data with your containerized applications. And talk a little bit about why NetApp is a good choice for your data management platform for all of your containerized data needs, really. So before we get started, usually when we do these, we one of the top feedback items that we get is, holy cow, there are a lot of acronyms. It's acronym soup, and we at NetApp love our acronyms. If you've been following us for any amount of time, you're definitely familiar with that. And our friends at VMware love their acronyms too. So a couple I want everyone to be familiar with today is, so starting off at the top, and we're not going to go through all of these, but CNS. So when I say CNS, I'm talking about the cloud native storage, essentially management plane that exists within vCenter. And it provides integration between, say, the vSphere CSI and storage policy-based management in vCenter itself. So it provides that that connection that allows native storage policy-based management to be leveraged by, your Kubernetes administrators, your DevOps teams. I did just mention the word CSI. So what is a CSI? So CSI is the container storage interface. It's essentially a standardized way to perform data management tasks, like storage management tasks, through the Kubernetes framework. So it's a way to manage Kubernetes storage. And a couple other things here. So a persistent volume, or PV, if you're not familiar, is essentially just a storage allocation that can be consumed by a container or a pod, right? And a PVC is a way to claim that storage resource and associate it with a pod or some other resources, right? TKG, Tanzu Kubernetes Grid, and the various flavors of that. We'll be talking about that more in a moment. So the NetApp and VMware partnership, specifically when it comes to Tanzu. So this year, we have over a 20-year partnership with VMware, where we've had really a great shared vision and history of innovation, looking to increase the efficiency of the data center, right? And that goes from the era of machine virtualization, where everything was migrating from bare metal to virtual machines, virtual servers, virtual desktops, to take advantage of the efficiencies you can achieve with consolidation, getting rid of unused compute resources and consolidating on shared storage. If you look at the little chart there I've got on the side, move this little widget out of the way. So if you look at it in the middle, so we're actually celebrating 10 years of VASA and vVols this year. So back in 2012, NetApp was actually one of the reference platforms for the release of vVols. So with our 20-year history of VASA and vVols, we've learned a lot, and our VASA provider has evolved a lot along the way. And I'll be talking more about that shortly. But that dovetails into the work that we've done over the last 2 years with VMware to validate solutions based on Cloud Foundation, right? VMware Cloud Foundation is the new vSphere, and it's going to provide that cloud-like experience for on-prem services. So, and that's whether it's principal storage or supplemental storage with Cloud Foundation, certified both ways internally with our testing, and we've talked about it in a number of different webinars. But also with Tanzu, as soon as VMware rolled out support for first-class disks, we were able to validate that and ship a release of our VASA provider that supports first-class disks, which are essentially a VMDK that isn't owned by a VM. It's a first-class citizen within a vSphere ecosystem. And that allows you to take these storage objects and associate them with things other than VMs, such as pods, for example. And then looking forward into the future with announcements that have been made over the last quarter or so, where you'll be able to take advantage of NetApp data stores as a first-party service across all of the hyperscalers. Of course, you'll have to follow up with those hyperscalers to see, what the private previews are all about and how to get engaged with those. But those, again, have been announced by all three of the major hyperscalers. Looking into the forward, into the future, we're looking at improving our solutions to support Tanzu as we work with VMware to get more integration points, if you will, exposed through the cloud native storage management plane. Now, when I talk about NetApp integrating with a VMware ecosystem. Typically, the foundation for that integration is a free product that we have called ONTAP tools for VMware vSphere. And that really provides, let's see if I can get this animation to step there. There we go. Good enough. So thanks, David. There are three main components within ONTAP tools that provide that integration. The first is the vCenter UI enhancements that it provides. So what that does is it provides context-sensitive menus for you to simplify operations tasks for your vSphere administrator. So things like you could right-click on a data store and perform storage management tasks on it. There's also GUI enhancements, right, within the actual vCenter single pane of glass, right, the HTML5 user interface that will show you storage details, right, where it lives in the environment, what its actual capacity is. If you're using storage policy-based management, some things around that exist as well. Not to mention things like being able to generate reports right in the vCenter UI for things like data store capacity and performance reports, and as well as managing storage profiles, which we'll talk about later. The other thing is the API server. So ONTAP Tools is a REST API endpoint. And the purpose of that is to simplify the task of creating automated workflows within your VMware ecosystem. So for example, you could write a workflow that sends one REST API to ONTAP Tools that would perform a myriad of tasks. So instead of having to write different API calls for the ONTAP storage array to vCenter to any number of other things, you can send one API call and it will create volumes and LUNs or exports and map initiators, and then tell your host to rescan and create data stores and mount the data stores to additional hosts. All these things are simplified by just using a single REST API endpoint for building these automated workflows. It makes it a lot easier and less painful to adopt very simple automations just to improve the efficiency of your web front end or self-service portal, whatever you're using to provide your services. And actually, before I go ahead, let me go back to that one more time. So will also mention the VASA provider is part of ONTAP Tools. So that provides services for vVols and storage policy-based management and storage awareness. So you're able to see and manage storage with capabilities that aren't possible with just data protocols alone. And then the last thing there is the storage replication adapter, the server for the storage replication adapter that provides array-based replication for VMware Site Recovery Manager. So if you want to take advantage of SRM to orchestrate your DR workflows, you're able to take advantage of NetApp SnapMirror replication, even synchronous SnapMirror replication for an RPO0 solution. So here, really looking at kind of the whole NetApp portfolio when it comes to integrating ONTAP with vSphere. So for automation, we're going to have REST APIs that you can consume that I mentioned with ONTAP Tools. Our backup and recovery application, we have sample Ansible modules you can take advantage of, as well as ONTAP's own Ansible modules you can download and integrate. Monitoring is available through a number of products, as well as integrating through there we go. The slide steps aren't working too well for me, but that's okay. And then integrating through ONTAP Tools itself, again, VAI for storage acceleration, enhanced offloads, reporting, snapshot offload, even without VASA, all that's possible with these integration tools. So let's take a look at the Tanzu portfolio. And David, I see we have a question here.
Yeah, the poll on the screen I want to call everyone's attention to is, how familiar are you with VMware's Tanzu offerings? very familiar. Maybe you're using them already or considering using them, somewhat familiar. Maybe you've heard of them, a little familiar, or not at all. So I'm curious to hear your feedback on this. We appreciate your responses. Looks like kind of a tie here between somewhat familiar and not at all. It was still a good portion there in between. So thank you everyone who responded there to the poll. Chance, I'll hand it back to you.
Thanks. So that's great. It looks like we've got a great opportunity to do some learning today. So when you look at VMware Tanzu, it really does have a solution package, right, to meet pretty much any need that you might have. And it goes all the way from Tanzu Community Edition, which is a free open source, Kubernetes distro from VMware, to Tanzu Basic Edition, which gets you up and running with Tanzu Kubernetes Grid service and standalone and vSphere native pods, on up to Advanced Edition. So if you go all the way up to Advanced Edition, that's essentially a completely integrated DevSecOps stack with everything you could possibly need to run your DevOps environment with a fully integrated VMware solution. Now, each of these different licensed editions of Tanzu have different capabilities as far as what you can do with storage. So let's take a little bit of a deeper dive look at the technical differences. So if you remember a few years ago at VMworld, it's like 2018 maybe, something around that time frame, VMware introduced Project Pacific. And so Project Pacific was this concept of running Kubernetes pods natively on the vSphere hypervisor as a first-class citizen without having to set up a guest operating system and install your container runtime and everything in that. It runs natively on vSphere. And one of the advantages there is it's extremely efficient. It uses just the right number of amount of resources within the hypervisor, and it's extremely fast and efficient because it's essentially para-virtualized. Now, there are some limitations of why you might not use the vSphere native pods, and they are very restrictive. They're very fast, very efficient, and very well integrated into vSphere in terms of visibility and provisioning, management, and everything you can do. It's just really, really well done. However, there are some restrictions, so you can't go and log into your pod. You can't use other CSIs. You remember we mentioned CSIs earlier, container storage interface. You're really restricted to only using the vSphere CSI, which takes advantage of vSphere storage. So that might be vVols, it can be any number of other things, even vSAN. So you move up the stack a little bit to Tanzu Kubernetes Grid Service, which is the service integrated with vSphere that lets you manage Tanzu Kubernetes Grid standalone clusters within your vSphere environment. So that essentially you have your supervisor cluster that provides Kubernetes supervisory services within a given ESXi host cluster, and then you can deploy TKG workload clusters within that same environment and manage them through that kind of single pane of glass interface. And then all the way at the top, we've got Tanzu Kubernetes Grid Integrated TKGI, which is essentially an evolution of Enterprise PKS, which came to VMware through the Heptio acquisition back in 2019. So that's yet another flavor. And if we look at the solution stack kind of side by side here, you can kind of see what TKGI looks like with Bosch and running on top of NSXT for your network virtualization on the left-hand panel there. But then on the right-hand side of the slide, you're looking at what I think is a really good way to look at a unified platform, right? And what do I mean by that? So let's say you've got, and this is really one of the great things about the Tanzu portfolios, you can run native VMs, like your legacy apps, your line of business apps within VMs, just like you always have, right alongside vSphere native pods for those high-performing containerized workloads, right alongside guest clusters running, TKG workload clusters, all of it on the same infrastructure, sharing the same resources and doing it in an efficient way. So, looking at this a little bit further, why would you want to use Tanzu as the foundation for a Kubernetes self-service platform, right? So it gives you an open source aligned Kubernetes solution with a very simple deployment model that's vSphere integrated and brings multi-cloud support, right? Hybrid multi-cloud support. And it gives you a consistent DevSecOps experience, right? Your Kubernetes developers or your Kubernetes admins, they don't need to know if it's Tanzu or if it's Anthos or vanilla Kubernetes, whatever it is. It works exactly like any other Kubernetes distro from the administrator's perspective, right? If you're using the vSphere CSI, VM storage policies appear as storage classes in Kubernetes. There's automatic translation that happens. They don't need to worry about creating storage classes with that. We'll talk more about that in a minute. Or if you're using a third-party CSI like Astra Trident, that's going to give them the opportunity to take advantage of that as well. And of course, because you're using standard Kubernetes namespaces, you've got that the intrinsic secure multi-tenancy that Kubernetes gives you. And I just talked about the unified platform. vSphere gives you the option to have your legacy apps, your virtual servers, virtual desktops, all the VMware services that you've used for years, run it alongside a consolidated infrastructure with Tanzu as that Kubernetes platform. And of course, you're leveraging trusted partners, right? So NetApp and VMware they've been around together for decades now, partnering for decades now. And of course, they both have global support organizations that are available 24/7 in multiple different languages all over the world. So you really have a partner there that you can depend on any day of the night, right? Any time of day. And another thing to look at is the opportunity to elevate your existing IT skills. IT skills are something that we talk about a lot these days, trying to maintain our staffing levels or even level up our staffing levels, like in this example. So because all of this is vSphere integrated, you're able to take advantage of a lot of your pre-existing staff skill base. So you already have experienced and really good vSphere administrators. It doesn't take much for one of them to take and turn up a Tanzu workload cluster, right? Or enable workload management on an ESXi cluster and start building out pods on it. So you're able to take these skills that you already have, take them up to the next level and really enable them to be part of a DevOps team. So let's dig a little bit deeper into the CNS platform, a cloud-native storage platform. So starting with vSphere 7, they introduced support for vVols, right? And so vVols take advantage of storage policy-based management to provide VM or even now pod-scale granular controls across an environment that allows you to consume advanced storage array capabilities without necessarily having to become a storage administrator. The policies themselves will simply tell you what the capability is or give you the option to take advantage of a capability and you just use it. You don't need to know how to go configure an ONTAP storage array or an element storage array or whatever the case might be. Secure multi-tenancy, again, intrinsic to Kubernetes namespaces. And, I mentioned that VM storage policies that are, the foundation of policy-based management that you can use with vVols. Traditional storage as well, even including, vSAN is a storage policy-based management based storage platform. So the cloud-native storage platform, sorry, I lost my train of thought, I had a message pop up. Cloud-native storage management plane takes these VM storage policies and translates them into Kubernetes storage classes within the namespace. So you will take, as a vSphere administrator, you'll have a VM storage policy. You can take and associate that with a managed namespace within vCenter. You can assign a unique quota to it. So you could take the same policy and assign it to multiple different namespaces if you want. And with each one, you can, assign a specific quota. So let's say you have, 10 petabytes of storage. You can take the same policy, assign it to everybody, and give each one, say, a 1 petabyte quota so they can't go over that. And it allows you to have these fine-grained granular storage controls that allow the VASA provider or whatever storage you're using to automatically provision the persistent volumes and manage persistent volume claims for all these different storage resources based on whatever classes of service you define within vCenter. And all of that gives you the capability to have predictable, consistent, and reliable storage services because you know how this is going to work because you were able to take a kind of a cookie cutter approach, if you will, by defining quality of services, in terms of, how many IOPS do I want a particular VMDK to be able to consume, right? So you eliminate these, noisy neighbor problems that you oftentimes find in highly dense environments. Now, I've mentioned vVols a lot, and I've mentioned ONTAP tools a lot. If you were at VMworld last year, or if you were at Insight last year as well, which was right after VMworld, we announced a new scale-out VASA provider that's launching this year. So this is a whole new architecture. And I mentioned we're celebrating 10 years of vVols this year at NetApp, and along the way, we've learned a lot with our appliance-based VASA provider. And what we've learned is that you need to be able to scale, and you've got to be able to scale across vCenters. You've got to be highly available across every layer of the stack, and you've got to be able to meet massive demand, right? Especially with containers, because container sprawl is real. And when you start seeing thousands and thousands of persistent volumes get deployed, you're going to understand that vVols make a lot of sense, and managing them at scale with a scale-out VASA provider makes a lot of sense. So what is a scale-out VASA provider? What is NetApp's next generation vVols solution? So it's based on a containerized microservice architecture. It's horizontally scaling based on whatever parameters you define. Of course, there are parameters out of the box that will have it automatically scale, deploying new pods to support the workload. And it's also essentially, self-healing, right? So as a pod, if a pod dies, like say you've got one of your worker nodes that it runs on fails for some reason, new pods will get spun up to replace it on whatever hardware is remaining in the environment. We've tested this with over 100,000, significantly over 100,000 vVols on a single VASA provider across 6 vCenters, 800, actually well over 800 ESXi hosts. And this is, well beyond a 6x scale improvement over what our legacy vVol solution is able to provide. So think about whatever you know about NetApp and vVols, it's changing this year, right? It's highly available, it's highly scalable, and it's highly resilient. It provides state-of-the-art instrumentation and visualization through built-in, Grafana and alerting and Prometheus. Everything that you expect from a modern cloud-native architecture is going to be part of this application. So we do have some early adopter activity going on right now. If you are interested in learning more about this or possibly taking part in an early adopter program, just reach out through your normal NetApp contacts, whoever you normally deal with. And they'll be able to set up a conversation about that. So I have talked a lot about vVols. I've talked about vSAN. I've talked about traditional storage and data management with Tanzu in general. But what does the architecture look like? So what we're looking at here is kind of a visualization. So you've got all your Kubernetes pods, and they have persistent volumes and persistent volume claims for storage running either on ONTAP or Element or Cloud Volumes ONTAP, whatever the case might be, right, wherever it lives. Here you can see the vSphere CSI, the vSphere Container Storage Interface that lives within your Kubernetes cluster, communicates directly with the CNS control plane. And the CNS control plane can talk to, all the rest of the vCenter components within the VCSA. And the VCSA, if you're using vVols, can talk VASA to the VASA providers that it has registered. So in this example, we've registered the Element VASA provider, and we've registered ONTAP tools, the ONTAP VASA provider, which in turn talks to ONTAP 9. But that's not the only option. That does provide fantastic integration with vSphere, and it allows your vSphere administrators to have really fine-grained control over your storage capabilities. But what if you need some capabilities that aren't possible with the vSphere CSI? There are some things that it can do that other CSIs can't, and vice versa, right? What if there's another solution that better meets your needs? So here's where something like NetApp Astra Trident comes into play. Excuse me. So Astra Trident brings in some new capabilities and is able to communicate directly with Element or ONTAP. And you can build storage classes that expose these different capabilities to your Kubernetes administrators. But there's some difference there, whether your Kubernetes administrators are managing these things or if your vSphere administrators are managing these things, as well as what protocols you're using and where things live. So Alan, I've got him here. I've also got Bala from both of these guys are from the Astra Trident team. Bala's here to help answer questions in chat. And Alan, being one of the experts on Astra Trident, what are your thoughts on this architecture and where the difference between the vSphere CSI and the Astra Trident CSI kind of come into play?
I think that's a great question, Chance. I look at mainly, as we say here on the slide, where we talk about there are some greater capability sets available when you're using NetApp Astra Trident. Of course, Astra Trident is NetApp's preferred storage integration solution for Kubernetes. It's developed in-house. It's open source, fully supported by NetApp. Back-ended by our Element storage systems, ONTAP storage systems, as well as Cloud Volumes, ONTAP's Cloud Volume Services, Azure NetApp Files, if you're working in the cloud. So it has a number of feature set capabilities that are not available by default with the vSphere CSI driver. Primarily the ability to do snapshotting of volumes. And if you know NetApp, one of our big things for years has been our data efficiency with our snapshots, flex clones, things like that. And also its ability, since it can map to NFS directly, it can provide read-write many volumes. So that's another big thing. But, the rest of this presentation is going to be dedicated to storage here. So I'm going to go ahead and take it over to the next slide. And so first, I do want to ask, I just mentioned this. Do you use or plan to use CSI snapshots?
Yeah, that's a good question. And the poll is on the screen. I encourage everyone to respond to that. We do want to hear your feedback on this. Alan, do you want to elaborate just a little bit on when you say CSI snapshots? Maybe a little more definition on that for those who are not quite sure?
So I see it's we're actually kind of leaning towards no right there quite a bit, and I think that's interesting because I see some major value with the ability to snapshot an application, roll back the persistent volume, make a clone of that persistent volume, and attach it to another application. There's quite a bit of things that I do in day to day with my applications in Kubernetes that I leverage snapshots all the time. So, and then, having, NetApp snapshot copies, backing those where the snapshots themselves, as they're taken, don't use additional disk space, as the snapshot's taken is a major boon there. So.
Excellent. Well, thank you for elaborating on that. Sounds like there's some education here to be done. And so I'll hand it back to you.
Okay, so I'm going to continue here, and right now take a look at the slide where I have placed the Astra Trident CSI driver side by side with the vSphere CSI. Now, the main thing you have to think about here is kind of how Chance mentioned earlier when it comes to ONTAP Element, the VASA provider. NetApp's storage systems in both of these cases are providing the backing storage. So when it comes to storage efficiencies like deduplication, compression, compaction of data. That's going to be available on the back end no matter what. Where you get the different feature sets that can depend on your workload performance is the fact that Astra Trident gives you the ability to create read-write once volumes on block formats, and that would be like iSCSI to element storage or iSCSI to ONTAP. Or it gives you the ability to do a read-write many if you're doing NFS to ONTAP. Now, you see on the vSphere driver on the right, NFS is a supported storage protocol. However, in the case of the vSphere driver, whether it's vSAN, VMFS volumes mounted by block, NFS volumes, that's more of a traditional how you do a vSphere data store with NFS. It creates, the vSphere data store is mounted off an NFS server, but then it creates VMDK files in it as block devices, and that is what is mapped to your container, which is why the limitation is there of having the read-write once volumes, which cannot be attached to multiple containers or pods at the same time. So when you have workloads, AI/ML type workloads, or any type of workload where you want to do like a rolling upgrade of an application so that you can deploy the new application side by side and attach a back-end data vol. Having read-write many is a major factor there in allowing you to run those types of operations. So another thing is the way of provisioning. If you heard Chance mention earlier, Trident takes into account the Kubernetes admin or the actual DevOps engineer or user and their ability to provision storage compared to the VMware admin. So in this case, when you look at Trident, and I show all the different backends that are there, I mentioned before, but all it takes is an initial configuration by the IT admin where they configure the storage backends. Trident is installed in the deployment of Kubernetes. They add the backends available to that cluster and then define the storage class there in Kubernetes. Once that is done, it's all up to the end user inside of Kubernetes. So the developer can then make the PVC request. And what we have here is the PVC request where they're asking for one volume at 10 gigs. They want it to be read-write many, and they're asking for their gold tier storage class. In that case, Trident will then go for the creation of the PVC. It will find the backing storage pool that will satisfy that defined storage class. And when you set up these backends, you can choose to put them on different aggregates on different, if you have a NetApp fast system with hybrid storage, so you have spinning disk and all flash disk, or if you have an AFF array with all flash, if you have cloud storage pools, Trident will find the storage pool that will meet the requirements of that storage class. And that's where it will provision that volume. So it'll create the volume in that storage pool. It will then take that volume, map it to the PVC, and then go ahead and take care of mounting that into the container for you. So what I've got here quickly, and I hate to say this, you're not going to be able to escape my voice. I've got a pre-recorded demo here for a few minutes talking over and showing how the Trident provisioning process works when you're inside a Tanzu cluster. I hope you enjoy. My name is Alan Cowles, a solutions architect here at NetApp, and today I will be demonstrating deploying an application with persistent storage in VMware Tanzu TKG 1.3.1 using NetApp Astra Trident. We begin our demonstration assessing our environment by running Tanzu version, showing that we have installed TKG 1.3.1. We follow that by running kubectl version to show that the current installed server version is Kubernetes 1.20.5 VMware.2. We can run kubectl get nodes and take a look at the cluster nodes we have deployed in TKG, a single master control plane node and 3 worker nodes. We can see that NetApp Astra Trident is installed by running kubectl get pods in the Trident namespace, which shows us the Trident operator, the orchestrator, and pods installed on each node in the cluster. We can run Trident control version against the Trident namespace to see the current release that is installed, in this case 21.10.0, which is the latest release from the month of October. We can also use Trident control to observe the backends that we have to support NetApp storage. Here we have configured an NFS backend using the ONTAP NAS storage drive. The backend is online and currently has 0 volumes associated with it. This backend connects to an ONTAP system in my lab, K8's ONTAP, which is running ONTAP 991P2 and currently has many volumes deployed for our Kubernetes testing. Returning to our console, we can continue by installing the application using Helm. Running helm install WP using the image provided by the Bitnami repo for WordPress in the namespace WP and setting a few options for username, password, and our global image pool secret for our Docker Hub registry. Once the chart is deployed, we can check on the status of the application by running kubectl git pods in the WP namespace, and we can see that it is pending. Running that again, we can see that one of our pods is running and the other container is currently being created. Using kubectl, we can also check on the status of our PVCs in that namespace. Notice it has created 2 of them. They are currently bound, and we get the PVC IDs with specific volumes. One of them is 8 gigs and the other is 10 gigs. We can take a look at these PVCs on our ONTAP system by looking at their unique IDs. First of all, we'll look up Trident_PVC4AD and take a look at the one that presents itself. In this case, it's our 8 gig volume that we just looked at. Changing the end of that to C131, we see our other volume here on our ONTAP system. It's our 10 gig volume. Returning to our console, we can run kubectl git pods in our namespace and see that our application and both pods associated with it are currently running. Running kubectl git services in the namespace, we can see the external IP where the app is exposed. Copying and pasting that over to our browser, we can pull up our WordPress website and show that our application is running. I'd like to thank you for watching my demonstration today of deploying an application with persistent storage in VMware Tanzu TKG using NetApp Astra Trident. I invite you to check out cloud.netapp.com/Astra to get started with NetApp Astra Trident today. Okay, so hopefully I didn't bore too many of you off with that, and you found it informative and useful. So continuing our presentation here, we're going side by side with the feature comparison, as we mentioned. The main thing we've already talked about is having that topology-aware volume provisioning and noting that we have block only with the vSphere driver versus block and file with Astra Trident. Also, we have the inability for the volume snapshots, which with our quiz question earlier didn't seem to be much of a concern, but just pointing out that feature set is there and quite useful, which you might see in our next demo. Finally, talked about the read-write many volumes for the different types of workloads. One of the benefits that you get out of the vSphere CSI driver right now is its ability to support Windows-based Kubernetes nodes. So if you are deploying Windows containers, you'll see a major benefit there for the actual vSphere CSI driver. Overall, pretty comparative if you look at everything else when it looks at whether encryption's available, whether you can expand the volume offline, how you can whether you can map the volume to for raw block or format the file system you would want to see on there. So overall, they're quite comparable, and you just have to choose what works best for you and the applications you're deploying. So another quiz question here. David?
Yeah, the question on the screen I want to call everyone's attention to is, do your Kubernetes applications require read-write many volumes? And so this is a specific type of volume. Has multiple applications writing to it and reading from it. Is that right, Alan?
Yeah, it's the ability for different pods, different nodes to all access the same volume at the same time. Like okay. I said, it's majorly used in the AI/ML type workloads or in the any application with like a rolling upgrade where you have a persistent data set that will migrate from one instance of an application to the newly upgraded version of the application.
Okay, excellent. Thanks for clarifying that. So it looks like kind of a split really between yes and no. So half and half, I would say in general. Alan, I'll hand it back to you.
All right, we will continue. So we want to discuss why do we want to use NetApp for Tanzu? Basically, we look at NetApp's data management systems for Tanzu and other Kubernetes distributions is that we have solutions that will fit any Kubernetes storage need. Whether you need that read-write many, you need the snapshots, or you don't, you can do those with Trident, or you can use the vSphere driver with NetApp as your backing storage. As NetApp says, we like to say we have best-in-class performance and resiliency, both on-prem and in the cloud with ONTAP. We have built-in support for secure multi-tenancy. Our element storage systems have individual tenants that are created for every storage volume provisioned. ONTAP systems have SVMs that help us split workloads and ensure, and Trident itself is set up with authentication to dedicated SVMs. So each user's workload can be separated from the other users, in your company or in your department. We like to talk about our data fabric, the fact that we do have, on-prem solutions with FAS and AFF and SolidFire. We have our cloud-based solutions with CVO, CVS, ANF, and all of the technologies that allow you to connect those, bring data back and forth easily from on-prem to the cloud. And pretty well all of our solutions are available to be managed with REST APIs. ONTAP and Element both are designed to allow you to automate any of your workflows. We have Ansible modules that we publish for ONTAP management that make it easy to set up your own automated scripts and control your systems in that manner. And then, lastly, but not least, definitely, is we have a history of trusted partnerships, strong track record with VMware, with other third-party companies that have Kubernetes distributions out there, and we work with with any of their products, honestly, and we do it well. So one more demo. This one's a little bit of a sneak preview right here. This is something that, mad scientists have been doing up in the lab right here. This is NetApp's Astra Control Center, which is, it uses Trident as a major, its actual backend into ONTAP storage systems, but it gives you a ability to snapshot an application and its backing data in a stateful manner. Giving you an application consistent snapshot. You can then migrate that. You can clone it. You can migrate it from one cluster to another. You can take those snapshots and just use them for disaster recovery like snapshots are intended for. So bear with me for a few more minutes here. I'm going to show off this demo, and I hope you enjoy it. My name is Alan Cowles, a solutions architect here at NetApp. And today I'm going to demonstrate how easy it is to clone an application between clusters in VMware Tanzu TKG 1.3.1 using NetApp Astra Control Center. Starting from our dashboard, you can see that we have one managed application and two managed Kubernetes clusters and one managed storage backend. The application that we are managing is a WordPress application installed in our Tanzu workload cluster. This cluster is but one of two clusters discovered and managed in our environment, running Tanzu with an application available to be managed. The other cluster is dedicated for WordPress and is also Kubernetes of the same version. We have also discovered storage backends, our ONTAP system running ONTAP 991, and have created a generic S3 bucket for the Tanzu Astra purpose, which is currently available for use by NetApp Astra Control Center. In order to clone an application from one cluster to another, we select the application and go to the Action menu and select Clone. We then change from our workload cluster to our WordPress cluster, and we click on Next. we notice that the application with its existing namespace and existing cluster now have a new name, new namespace, and a new cluster destination. We click on Clone to continue. You can see that the application is now in the discovering process, where it will remain for a while as the application is first copied locally and then to the remote cluster. While our clone process is running, we can go ahead and take a look at our app in the console. First of all, let's go ahead and look at the pods that are in our original namespace. We can see that there are two, MariaDB and WordPress. We can then take a look at the services that are available in that namespace and get the IP that is exposed and pull up our WordPress instance. The cloning process for this particular WordPress instance takes about 20 minutes, but for the purpose of this video, we have trimmed that down. When the clone is complete, the application will become available in Astra Control Center. We can see that it is now located on the WordPress cluster, and we can pull up our console, switching our kubeconfig to the one for that cluster in order to take a look at that environment. If we do get pods in our newly defined namespace, we will see that we also have two pods here, MariaDB and WordPress. And if we take a look at the services in that new namespace, we can collect the IP from the new service, which we notice is different from the old one. We can take that IP, add it to a browser, and pull up our WordPress instance there as well. I'd like to thank you for watching my demonstration today of non-disruptively cloning an app using Astra Control Center in VMware Tanzu TKG. And I invite you to check out cloud.netapp.com/Astra to get started with Astra Control Center today. Okay, so I hope you guys found that as entertaining and as informative as I did, and just overall neat. The ability to take your application and tell it you want it to live in another cluster, and non-disruptively it moves it over, creates the service needed to expose that application, and you're up and running. So I find that pretty awesome. So we're coming near to the end of our presentation here, so we've got a few key takeaways. First of all, I'm going to talk about how Tanzu has multiple editions, TKGI, TKG, and TKGS, and the vSphere pods. Finding out which one fits your specific workload does require careful analysis. Figure out which one works best for you. Believe that storage is a core requirement for Kubernetes and containerized workloads, especially those that are to remain persistent. And that there is more than one way to consume NetApp storage for Tanzu, whether it's that vSphere CSI driver with the VASA backend or Astra Trident. If you would like to get started with Astra Trident today, I have a GitHub link right here so that you can pull it and install it in your cluster. Like I said, it's open source, allows you to access your NetApp clusters and provision storage straight away. We also have a demo for Astra Control if you'd like to try it. It's available at cloud.netapp.com/Astra. Here's some additional information, some resources that we find valuable. So you can follow any of those links at your leisure and discover what's available there for you. So in the end, I want to thank you for joining me, and I'm going to turn this back over to David.
Absolutely. Yeah. Great presentation, Chance and Alan. I learned a lot on the event today. Thank you so much for being here. Really cool demos. I know that the experts from NetApp have been answering questions electronically, and it looks like they've covered all the questions that have come in. So we really appreciate that. Alan and Chance, thank you so much for the great presentation today.
Thank you.
Yeah, you're welcome.
And I want to call everyone's attention there to the handouts tab for additional information. There are links right there to download Astra Trident and try Astra Control for free, as well as a link to the joint VMware NetApp homepage where you can find additional resources. Thank you to everyone for the excellent questions that you submitted as well on the event. Before we go, I do want to announce the winner of our Amazon $300 gift card. This is going to Tim Cross from Missouri. Congratulations, and we'll see you next time. Have a great day. Bye-bye.